Hi everyone. Today we're going to learn a new unit. We're going to start a new unit called linear functions. This is not on Friday's test. If you remember when we memorized all the different types of functions, one of them was linear. So this new unit will focus just on linear functions. So what does a linear function look like? Well, the graph looks like a line. You'll always see, like we talked about, a line. So you'll see a graph that has some sort of straight line. And its equation, which you memorized for your test, is y equals mx plus b. We're going to be talking about that for this in some upcoming lessons. But for today, we're going to look at the most basic way of graphing a line. A line is made up of points, right? The points are on the line and they are connected. We don't always see all the points because there are infinitely many points. So if we just find a few of them, we could then figure out what the graph looks like. So we do that. We figure out what a couple of points would look, what a couple of points that are on the line by making a table of values. The table of values is the x and y coordinates. This doesn't make straight lines, but so you're gonna make a table and you're gonna set up 5 rows. 1, 2, 3, 4, 5, and you pick any number that you want for the x. Okay, I'm making a note. Pick any number for x. You're going to plug it into the equation. So if you think about the function machine, the input and the output, you're picking the input. You put it into the function, and whatever comes out for y is your output. And then you're going to graph those coordinates. So usually I will try to pick numbers that are small, and I'll pick a couple of negatives and a couple of positives. So I like to pick -2, -1, 0, 1, and 2, but you can choose any numbers. The only issue is sometimes if you pick a number like 7 or something that seems like it's not too big, when you multiply it by something else and then add, it becomes very large and you can't graph it on the grid because there aren't enough spaces. But you can and technically pick any value that you want. So I usually pick those. I'm going to plug in -2. So in your mind, you should be doing some math here. -2 times the -2 for x is +4 plus 1 would give me a y value of 5. Okay, and then we're going to do the same thing with -1. I'm going to take -1, I'm plugging it in here. -2 times -1 is +2. +2 plus 1 is 3. You can always use a calculator for these. Then I'm going to plug in sorry, that erased that. That was 3. Then I'm going to plug in 0. -2 times 0 is 0, plus 1 is 1. So my y value is 1. Next, I'm going to substitute 1. -2 times 1 is -2. -2 plus 1 is -1. Again, feel free to use your calculator. And then 2 is going to get substituted. -2 times 2 is -4. -4 plus 1 is -3. So these are now xy coordinates. So if you remember when we're graphing, the x value, you go left or right. Left if it's negative, right if it's positive. And the y value, you go up and down. Up if it's positive, down if it's negative. So this tells me to go 2 to the left, 5 up to plot that point. So I'm going to go 2 left, 1, 2, 3, 4, 5 up, and there's my point. Oh. 1, 2, 3, 4, 5. There's my point. And then my next point is -1, 3. So that means I'm going to go left 1, up 3. Oh, that's the wrong kind of marker. There. And then I have 0, 1. 0 says don't go left and right, but just go up 1 unit. 1, -1 is right 1, down 1. And then 2, -3 is right 2, down 3. Okay, once you have your line, you take your ruler, which I'm going to use the ruler on here. That's here. And you take your ruler and you draw a straight line. Your line is going to go past the points. So you're not just connecting the dots. Remember, these are just a couple of points on our line. You're going to go past it because the line is infinitely long. And let me just get rid of this ruler. And then you're going to add arrows to your line to show that it goes on infinitely in both directions. And your final touch is you're going to label the equation. Remember, f of x means y. So f of x or y equals -2x plus 1. That's the name of the equation. You label the name on its picture. And that's how we graph a line. Okay, so we're going to go to the next example. Now this time I'm multiplying the x value by a half. So I'm going to want to choose numbers that are even so that I can avoid decimals. So I'm going to make my table. I can get decimals, but it's just sort of annoying. So I'm going to make 5 rows, 1, 2, 3, 4, 5. And remember that you're choosing the x value. So I'm going to pick, instead of -3 or -2, I'm going to pick -4. And I'm just choosing even numbers, -2, 0 is even, 2, and 4. And I'm just plugging into the equation. So half of -4 is -2. And then -2 minus 3 is going to give me a y value of -5. Then when x is -2, I'm substituting in here. Half of -2 is -1. -1 minus 3 is -4. Then I'm substituting 0. Half of 0 is 0. 0 minus 3 is -3. Next is going to be 2. Half of 2 is 1. 1 minus 3 is -2. And then 4. Half of 4 is 2. 2 minus 3 is -1. Okay, I'm going to plot the points. -4, -5 is going to be left 4, 1, 2, 3, 4, and down 5, 1, 2, 3, 4, 5. That's here. -2, -4 is left 2, down 4. That's here. 0, -3 is just down 3. 2, -2 is right 2, down 2. And then 4, -1 is right 4, down 1. There's my line. You take your ruler, which for me is here, and I have to erase that. I'm going to draw this line. Okay. And let me erase that. I don't know how that came up. And then we're going to do arrows and label the equation on the line. Y, or f of x, equals 1/2 x minus 3. Okay. Next, we're going to talk about the solutions of a linear function. The solutions are what we call points on the line, basically. These are the points on the line. So there are infinitely many solutions to a line. If I draw a line, any point on the line is a solution, and there are infinitely many of them. So a common question will be whether a particular point is a solution of a particular line. So when they ask you in example 3, is -3, -8 a solution of the function y equals 2x plus 2? They're asking you, is this point on this line? Okay, so to do that, instead of graphing it, you could graph it to see if that point is on the line, or you could remember that the first number always is the x-coordinate and the second number is the y-coordinate, and that we could substitute these values in for x and for y, which is over there. So instead of y equals, I'm going to write -8 equals. Instead of 2 times x, I'm going to write 2 times -3 plus 2. And if this comes out to be true, then that means that that point was on the line. If it's not true, then the point is not on the line. So -8 equals -6 plus 2. -8 does not equal -6 plus 2 because that's -4. So no, it is not a solution. Okay, if I had gotten the same value, then it would be yes, it is a solution. And finally, sometimes there'll be a missing number. So here they give you a missing value of b, but they give you the y-coordinate of -10. So we're really just looking for the x. So we're going to go into the equation. Remember, f of x just means y. This is really y equals -3x plus 5. I'm going to substitute x as my b as my x, and -10 as my y. So instead of y equals, I'm writing -10 equals. Instead of -3 times x, I'm going to write -3b plus 5. And I'm going to solve for b. So I will subtract 5 on both sides. I have -15 equals -3b. Divide both sides by -3, and b equals +5. That's the value of b that would make this point on the line. All right, so you're going to have some practice problems tonight on this. It's pretty straightforward. Please use your notes to help you. Every problem is just like a problem in the notes. All right, thank you.